Hololens is a mixed reality device. It is something completely new.
You're still in your normal physical environment, but then you see things on top of that.
It is technology that will change the world.
A big part of Alex's original vision was about that holodeck. How do you build the holodeck? We wanted to provide a demo that showed the best hologram you could ever see. Better than what you can see from a 3D movie, better than what anyone had really seen in the world. We wanted to create something virtual that looked like it was real.
It's not just the lenses, which are magic. It's not the cameras, which are magic in themselves. It is a full-fledged computer on your head.
We have something like 14 subsystems between camera modules, thermal systems, optics, eye tracking cameras, head tracking cameras, a depth camera, speakers, and 2 main circuit boards.
We had labs in a basement nobody knew we were doing. We covered all of our windows with butcher paper. We were all working in one open room together, which ended up being like 30 people in that space at some point.
I came on board, but didn't know exactly what I was going to be doing, but was told it was a super challenging project that nobody in the Bay was doing and nobody we believed in the world was doing.
We didn't really have the prototype lab. So we would go blunder around, figure our way out, spend a month and build a unit.
Within our mechanical engineering team, it was clear to them that the only way they were going to be able to succeed was to have a world-class prototyping facility co-located with our engineering.
The prototype lab is an essential part of our overall mechanical engineering team.
We're trying to build a world-class prototype lab, so we have to be able to do just about anything that comes across our desk.
What was a 5-day turnaround, 6-day turnaround before, it's become a 24-hour turnaround. So in theory, I can do 6 different iterations in the same time as I could do 1 iteration before.
We do a lot of 3D digital printing, SLS, PolyJet. We have a universal laser cutter that actually cuts vinyl, plastic, acrylic, paper, felt, foam. Bringing in the SLS machine, that was a game changer. SLS is selective laser sintering. It's a machine that holds a nylon powder, a bona fide plastic, that is then laser sintered layer by layer to form a component or a part. This is a 5-axis fixture that we created in about a day and a half. From concept to actually printing, and I had it on my director's table in like day 2. Oftentimes they're like, oh hey, just give it to the job, they'll do it, right? And 99% of the time, yes, we can. Premiumbeat.com. Something like this. Actual memory foam that when you squish it has a little bit of memory. But this is actually 3D machined. It's got a contoured surface here. It's got a contoured surface on the back. Once we did this is about 20 millimeters thick. They're like, great. How about you doing 6 millimeters, right? So we go from perfecting it and saying, yeah, we know how to do it now. In fact, the representative of the company that handed me this foam says, I've never seen it done. Said, come back tomorrow.
We submit parts. It can be a regular SLS 3D printed, it can come off the object, it can be CNC.
As long as you get your prints in by 3 o'clock, you can have parts on your desk by 10 a.m. the next morning, and as far as I'm concerned, that's the fastest prototyping shop there is in Silicon Valley.
ProtoZero is our first go at trying to put everything together. In the design phase, we usually have a series of prototype builds that are done at our actual factory. But the first build is here with 3D prints.
Monday morning, we all come in here and start kitting our parts, which means we're going through, we're getting them all prepped into sub-assemblies, or however they're going to show up at the factory when the product's actually being built.
Before that, we were just looking at it on the computer. It's in an assembly in CAD, and we can see it all fitting together, but it's not real until you print it, until you manufacture it and actually try to get it to go together.
We start off with a bunch of different iterations. We look at whether or not the device should be horizontal. We look at whether or not it should be angled. We also made a couple that have what we refer to as the dog leg. And by doing that, we are all looking at whether or not we can get a better grab of the inion, which is the bump on the back of most people's heads.
We try our best the first time to make it all go right, but of course there's always iterations, and it's best to catch them at this early stage. We're trying to assemble something that no one's ever made before, and we've made all of the puzzle pieces.
During the Proto Zero build, everybody is over in the shop all day long, working on building things, seeing how parts interact, and really bringing the designs that they had in CAD to life on the table there.
The first day, we'll get to a certain point, and then something may not work, something will stop that whole build because, hey, this is in the wrong place. They modify their files, they resubmit to my team. The next morning they come in, we have all the parts washed and cleaned, and they do it all over again. They start from part 1. Okay, part 2.
The number of prototypes that were actually made and tested on ourselves and tested with our management here, 30, 40, maybe even 50 different iterations. In the first couple months of our design cycle, we will come up with the most harebrained ideas and just see if it sticks. Some of those things you think won't work. Some of those things surprise you and actually do work.
It's a big savings just for the morale of the team when you talk about, hey, guess what? We don't all have to pack up, leave our families, and go overseas for a couple of weeks. Wouldn't you rather walk a couple hundred yards down to the lab, work on the build there, learn everything we need to, and then get back in time for dinner? That's huge.
It allows us to actually fix a lot of things in our design before we spend all the money to release for hard tooling. And so it just gives us that little bit of extra confidence that when we show up to the first tooled build, we're going to be able to put the thing together and it's going to fit the way we intended it to fit.
The first time we ever did it, it took 2 weeks. Nowadays, we're doing a Proto Zero build in about 3 or 4 days. By the 5th day, can I say we're barbecuing? Yeah, we're barbecuing.
There is a sense of accomplishment at the end, and you have more of a sense of confidence that your design will actually work because you've validated it in some tangible way now.
If we're not taking risks, so we're never failing, there's something completely wrong.
There's a little bit of scary in everything we do. You've got to take on something that at the beginning of the program you don't know how to do it. The team has to be able to put up with not getting it right the first time. So we have to be able to fail fast and try and not feel like we've done something wrong. So that's really become a part of the culture of the team. It's in the prototyping, it's how we design and develop. It's not iteration, it's invention.
Coming from the perspective of a very young engineer with lots to learn, there's never a shortage of support and knowledge given from your peers.
I still have the same core set of people that I have started with. In fact, I still have the same set of people that I did my new employee orientation with. That's because of what we build and because of how we build and how we are together as a team.
We spent nearly 5 years prototyping before we even got to the first builds of Hololens. A ton of the work that we did through that prototyping was really inventing the future ourselves.
It's amazing to look at what we first put together in early prototypes, where you had this crazy rig on somebody's head of all of these sensors bolted on just to show what we knew the experience needed to be.
HoloLens is always evolving. We're still creating it, we're still working on it, we're definitely not done yet.
I want to see a world where we can go out and basically see a dragon flying through the streets or see virtual graffiti. We're not quite there yet, but we're pushing. We'll be there.
We're writing the book of what holographic computing is. When no one else has solved all of these challenges before, we're the first people with a real mass market product. If you look to say, who are the experts in holographic computing? It's us. We're here.